Welcome grades 7 and 8 back to another science video today. It's hot outside, but you've got things to do. You shoot some hoops with your friends, then you go on a bike ride. When you get home, you mow the lawn, but now you're hot and you're also thirsty. How about a nice cold glass of salt water? We wouldn't last very long if we only had salt water to drink. But although we think of fresh water, not salt water, as being essential to life, salty ocean water sustains a wide variety of ocean life. In fact, most organisms on Earth would die without salt water. One taste of ocean water tells you that this water is not pure water. But it's not just water and salt either. Ocean water is a complex solution of pure water, solids, and gases. Ocean water is 95% pure water, with the other 5% made up of dissolved gases and minerals, made up of 80 different elements. Each cubic meter of ocean water contains 1.5 kilograms of dissolved substances. Even gold and platinum compounds are dissolved in ocean water. Ocean water contains many dissolved gases. The three primary gases dissolved in ocean water are carbon dioxide, oxygen, and nitrogen. Carbon dioxide dissolves most easily in ocean water and is present in the greatest amounts. Marine organisms convert carbon dioxide into organic compounds like carbohydrates, which they need to live. The oxygen gas in ocean water is essential for fish, ocean invertebrates, and other marine organisms. The nitrogen gas is an ingredient that plankton must have. Plankton, the smallest organism that serve as food for fish, are a foundation of marine food chains. The most obvious feature of ocean water is its saltiness. Have you ever wondered what makes oceans so salty? To answer this question, we have to begin in the atmosphere. Carbon dioxide in the atmosphere makes rain and snow slightly acidic. This acidic solution dissolves minerals in rocks. Wind, water runoff, and other erosion processes eventually carry these dissolved minerals to rivers, which in turn carry the minerals to the sea. In fact, each year, Earth's rivers carry about 400 billion kilograms of minerals to the oceans, and most of these minerals are salts. No wonder ocean water is salty. Over 99% of the ocean's salt content is made up of only 6 chemicals. Aside from the elements hydrogen and oxygen in water, the two most common substances found in the ocean are compounds of chlorine and sodium. Chlorine, as the chlorine ion, accounts for 1.94% of the ocean, and sodium accounts for 1.05%. These two elements, which combine to form common table salt, account for more than 85% of the ocean's salt. Other trace elements found in seawater include vanadium, zinc, copper, and mercury. The amount of salt in ocean water is called salinity. The salinity of ocean water is generally expressed in parts per thousands. Salinity can vary depending on the location and season. Enclosed seas, such as the Dead Sea and the Caribbean, have a higher salt content, ranging from 37 to 42 parts per thousand. Coastal areas near large rivers, such as the Amazon or the Mississippi, have a low salt content of less than 33 parts per thousand. Why would ocean water near rivers have less salt? The salinity throughout a body of water varies. Differences in salinity, along with differences in water temperature, create ocean currents. Colder or more salty water is more dense and will sink, forcing warmer or less salty water to the surface. These temperature and salinity differences form convection currents throughout the world's oceans. These convection currents distribute nutrients throughout the whole ocean. Salt from ocean water is an important product for many countries. Sea salt is cheaply extracted in countries with hot, dry climates, for example, Spain and Israel. First, shallow pans are flooded with ocean water. Then, the water is allowed to stand until the water evaporates, leaving salt deposits behind. Desalination is the process of removing salt from ocean water to obtain fresh water for drinking, irrigation, or industrial use. Countries that lack large fresh water supplies, for example, Saudi Arabia and the Caribbean nations, use desalination to get more drinking water. The oldest and most widely used method of desalination is distillation. In distillation, ocean water is heated to make it vaporize into water vapor. Coils filled with cold water condense this water vapor into pure water, leaving behind all the solutes found in ocean water. Distillation is an effective method of desalination, but it is expensive. Other methods include reverse osmosis and electrodialysis. Reverse osmosis involves forcing salt water against a membrane. The fresh water passes through the membrane and the salts remain behind. In electrodialysis, electrical potential drives the positive and negative ions of the dissolved salts through separate filters, leaving the fresh water behind.